and good day, geometry. We're going to wrap up Unit 3 with CO25, which is talking about some of the properties of isosceles and equilateral triangles, which you've defined before. You've worked with them before. You probably know what they are. But of course, now that we're in high school geometry, there are a few more things that we go a little bit deeper with. We've got some tools to add to your toolbox for proofs. And then just working with them in a more geometric sense. So starting with the base angles theorem, or the BAT, what this says is that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. Okay? The base angles theorem states that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. And that's essentially what an isosceles triangle is, right? We kind of already knew that just by knowing what an isosceles triangle is and what its properties are. But this is the theorem that you would use should you use this in a proof. So essentially what this is saying is that we've got this triangle here, okay? Two sides are congruent, and because of that, we know that the angles opposite those sides are congruent as well. And those are called the base angles because they're the angles that kind of make up the base of that isosceles triangle. Okay, so the converse of the base angles theorem, recognize that we have an if-then statement for the base angles theorem. The converse of that would be if two base angles of a triangle are congruent, then the sides opposite the angles are congruent. Okay, so the converse is just kind of the opposite of that. The opposite of our if-then statement. If two base angles of a triangle are congruent, then the sides opposite the triangle are congruent. So let me add a little bit of color to my first picture here. In red is what we know, and in green is what we can conclude. So in the base angles theorem, we know the sides are congruent. We can then conclude the base angles are congruent as well. In the converse here, again, dealing with an isosceles triangle, this time we know the base angles are congruent. So I'm going to put those in red. That's what we're told. That's what we're given. What we can then conclude is that those two sides are congruent as well. Okay, so it works either way. Two congruent sides means two congruent opposite angles. Two congruent angles means two congruent opposite sides. And that's what an isosceles triangle is. An equilateral triangle, all sides and angles are congruent. Okay? All sides, all angles are congruent. In an equilateral triangle, I'll do my best to draw one accurately here. It's not too shabby. Okay. In an equilateral triangle, we have the three sides are congruent, and the three angles are congruent as well. But remember that, since we have to have a total of 180, they all have to be 60. 60 degrees here, 60 degrees there, and 60 degrees there. The side lengths can vary because you can have triangles of different sizes, right? But as far as the angles go, the angles are congruent. They all have to be 60 in an equilateral triangle, right? So with those properties in mind, let's take a look at some of the examples down here. I am going to go over 3 of them with you. The other 3 are going to be in your Google quiz that you must get 100% on, so please do that tonight. just to kind of schedule for the week here. So obviously we didn't meet live Monday because you're watching this from home. Tomorrow, Tuesday, is an optional test prep session. You'll get your practice test during algebra. And if you want to stay after school to go over it, there's some things, particularly maybe proofs, that you want to talk about a little bit more. That'll be Tuesday, tomorrow after school from 1:45 to 2:30. Okay. Wednesday, since you're all in algebra also, Wednesday, if you want to stay after school for some algebra test prep, you actually start your algebra test on Wednesday, just because I think it'll take you 2 days to do it, and Wednesday shortened it because of math anyway. So you'll get your test Wednesday during class. If you want to stay after, kind of talk about things, go over things, you have that option. And then Thursday or Friday, talking about geometry again here, Thursday or Friday, you'll need to stay after school to take your geometry test. All right, so Tuesday, geometry test prep after school, optional. Wednesday, you'll get your algebra test. You'll finish it on Thursday, and Wednesday after school, optional algebra test prep. Thursday or Friday, you'll be staying after school to take your geometry test. So kind of a test-heavy week, lots of stuff going on, but the week before, 2 weeks off of school, that's kind of to be expected. So anyway, looking at some examples here. Again, my good friend Doug changed the Mr. Happy Pencil to a parallelogram. Thank you, Doug. But looking at some examples here, again, I'll go over 3 of them. 3 of them will be on your Google quiz, and that'll wrap up Unit 3. So let's talk about the first one, might as well here. I see I've got my 2 congruent angles, right? Which tells me that this is an isosceles triangle, which means those opposite sides will be congruent as well. And if my job is to solve for the variable, solve for x here, I don't really care about the 16 at all, right? Because I'm focused on those 2 sides that are congruent. I know that 5x plus 5 has to have the same value as 35. Being an isosceles triangle, those 2 sides need to be congruent. So the equation that I can set up there is that just, one side equals, one of my congruent side equals the other. From here, I've got a 2-step equation to solve. 5x equals 30, divide by 5, x equals 6. And I can just test that. If I plug in 6 for x here, does that side equal 35? Yes. Okay. And being an isosceles triangle, it should. Okay. We'll go over one equilateral triangle here. It looks like I kind of focus on the isosceles here, don't I? Only one equilateral triangle. Is that really all I gave you? Huh. Okay. Well, very well. So in this one, okay, being equilateral, and I know it's equilateral because all 3 angles are marked as congruent. And if all 3 angles are congruent, I know that all sides are congruent as well, right? So I need to set up an equation here that's going to allow me to solve for x and y. If I set 2x minus 3 equal to y plus 4, that's not going to be really helpful here, right? Because I've got 2 variables in one equation. And the value of one variable kind of depends on the value of the other. I just kind of lead myself down a path of frustration and a lot of work and not very efficient math here. So that 11 is important, right? Because if all 3 sides are congruent, that means, yes, 2x minus 3 will equal y plus 4, but it also means that 2x minus 3 equals 11. And that y plus 4 also equals 11, right? Because all 3 sides are the same. So I can add 3 here. 2x equals 14. Divided by 2, x equals 7. Subtract 4 here. Turns out that y is 7 as well. Will that always be the case in an equilateral triangle? If you have 2 variables, will they always be the same? No. The side lengths will always be the same, right? But the variables wouldn't necessarily be. Okay. The other one to talk about, let's look at, I suppose we can look at the last one, can't we here? Okay. 2x minus 11 is one base angle. Y plus 16 is the other one. My third angle is a 90-degree angle, so I do have a right triangle here, a right isosceles triangle. I'm looking to solve for those angles. Well, what do I know here? What relationships can I set up? I do know that 2x minus 11 equals y plus 16, right? Those two angles are congruent, being an isosceles triangle. But kind of like we talked about in the last one, I kind of run into a wall here because I have two variables to solve for in the same equation. That's not really going to work out for me. Okay. The other relationship I can say is I know that since I've got that right angle there, remember the corollary to the triangle sum theorem is that in a right triangle, my two acute angles, which are 2x minus 11 and y plus 16, the sum of those angles, so 2x minus 11 plus y plus 16, the sum of those angles has to equal 90, right? Because that 90-degree angle will bring me up to 180. So the corollary says that my two acute angles must equal 90. The problem here, though, is that, again, I've got one equation with two variables to solve for. If you had already completed algebra, you'd know how to do this. This is a system of the equations. You may have even done some of this before with substitution or elimination, if those methods sound familiar to you. So if you haven't done it, though, then right now, this is not going to be possible for you to solve unless you just start guessing and checking and eventually figure out and see what fits. But after PO 40, in algebra, which is kind of where we cover the substitution stuff, you'll be able to solve this no problem. So at this point, we can say that it is not enough info because we may not have enough information ourselves, enough knowledge to solve it, okay? But had you taken algebra, then you would. So the other three are going to be on the Google quiz for you. We've got, in this triangle, you'll need to solve for both x and y. Same thing with this triangle here, solve for both x and y. And same thing for this triangle here, solve for both x and y. All three happen to be isosceles triangles, so you get practice with that. But I'll throw some equilateral triangle questions on the quiz too, just to make it fair. So anyway, so there you go. Properties of isosceles and equilateral triangles. That wraps up Unit 3. Like I said, I already ran through the schedule, but just the abbreviated version. Optional test prep Tuesday after school, and then your geometry test, you'll need to stay after Thursday or Friday to take it. If that's not going to work for you, if you're going on vacation or quarantining or whatever, then get a hold of me so we can work out an alternate plan, because this test does need to be finished before break. All right, folks, that's how you math. Don't forget to like and subscribe. Hop over and take that quiz. Have a tremendous day.